Hey all you cool cats and kittens, Carole Baskin here, gonna help you with these confidence intervals, and maybe later I'll teach you how to feed a tiger.
You keep saying you got
Alright, let's get these practice pages out.
something you call
T.I. Joe, do you have T.I. Joe ready? And don't forget, T distribution chart. Gonna need this just like we're gonna need sardine oil. Good times. All right, so I've got 3 practice problems to hopefully bring it all together for you today. The first one is the U.S. Forest Service is considering additional restrictions on the number of vehicles allowed. Why not restrictions on the number of tigers, right? We shouldn't have so many captive tigers. It's just sad. To assess public reaction, the service asks a random sample of 100 visitors if they prefer the proposal. Of these, 89 say yes. All right, so the directions are kind of lacking. What we're doing here are 95% confidence intervals. We're trying to capture what the true values are for each of these. So this first one, you have to decide, is it a proportion or is it a mean? Well, this would probably be a proportion. This is a yes or a no question. So we're looking at 89 out of 150, right? That was their sample. So we're out to capture the true proportion. So P equals the true proportion of, let's see, visitors who favor restrictions on the number of vehicles allowed, and I'm just going to put that allowed to enter Yellowstone National Park. All right, so next thing we got to run through are our condition checks. All right, so conditions, our data has to be random, and there it is. It says random sample. So random stated. Next thing we want to verify is that it is a normal curve, right? Our sampling distribution needs to be normal because the Z star is based off of these normal curves. All right. Oh, sorry, my pet tiger was whining. Had to put him in the chair. All right, so now normal. Ring, 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 ring. Oh, hello? Jake from Stat Farm? That's right. We got to do our NP greater than or equal to 10 and our N times 1 minus P greater than or equal to 10. So since we don't know what P is, the next best thing is P hat. All right. So we want to have at least 10 visitors that say yes and at least 10 visitors that say no. When you look at it, 89 say yes. So yeah, that's more than 10. And then 150 minus 89 is 61. So 61 say no. That's okay. That's good. All right. So we've got 89 that say yes, and we've got 61 that say no. So we are good to go. So approximately normal. Check, check. The third one is independence. It didn't say that they sampled with replacement, right? They didn't put it back, put the people back, so to speak. So we might have double dipped. So we have to assume at least 10 times N. Our N is 150, so slap a 0 on it. Assume at least 1,500 visitors in population. So whatever sampling frame they use to pull their 150 sample, we have to assume there was at least 1,500 that were possible. All right, so conditions look okay. Nothing's violated. I don't have to proceed with caution. So now I'm going to do my formula work. All right, so we're out to capture what the true P is using a sample. All right, we know samples vary from day to day, hour to hour, minute to minute. So we have that plus minus, right? That margin of error that's going to come into play to give us that wiggle room. So plus minus Z star times the standard deviation, P hat, 1 minus P hat, all over N. All right, So our sample was 89 out of 150. You can write 89 out of 150, or let me see what kind of decimal that is. It's 5933333. Might be easier just to write 0.59. So 0.59 plus or minus. I'm going to skip the z star for a second. 0.591 minus 0.59 all over 150. Technically, this standard deviation should go all the way down. All right, so the z star, we're doing 95% confidence intervals. If a problem doesn't give you what confidence level to use, 95% is just assumed. All right, so your z star for 95% is 1.96. Once you've shown the substitution into your formula, which by the way, this is a 1 prop z interval, then you're gonna run to your calculator, T-I, Joe, and have it look it up. So head on over to Step World, scroll over to test. We're looking for 1 prop z interval, right? We're trying to capture the truth, which the truth is I did not hurt my husband, Don. I didn't. 1 prop z, there we go. All right, so our sample was 89 out of 150, 0.95 confidence level. So there we go. So the true proportion of people, visitors that do want restrictions is somewhere between 51% and 67%. So it looks like most people do want some restrictions on the number of vehicles allowed. All right, so our answer is 0.51 to 0.67. The last thing we have to do is our conclusion. We are 95% confident the interval 0.51 to 0.67, and what does our interval do? It captures the true proportion of visitors. I'm going to be a little bit lazy here. I'm just going to draw an arrow of visitors, right? I'm just stealing this line, who favor restrictions on the number of vehicles allowed. All right, so whatever you opened the problem with, you end the problem with. Speaking of ending my problems, thank goodness Joe Exotic is in jail. Am I right? All right, number 2. Change colors. How many people live in South African households? To find out, we collected data from an SRS of 48 out of the over 700,000 South African students who took part in the Census School Survey project. The mean number of people living in a household is 6.208, and the standard deviation was 2.576. Pause! Remember when I did that in class that one day? Oh, that was fun. Pause! Is this proportions or means? That's right, it's means. I mean, it straight up says it, right? Mean number, they give you standard deviation. All right, we're gonna do a 95% confidence level for the mean number of people living in a household in South Africa. All right, so mu is what we're after. We're out to capture the true mean number of people living in a household in South Africa. Careful, honey. Don't let the tigers out.
Be careful of you.
All right, so conditions. All right, random. There it is, SRS. So we are good. So random stated. All right, said SRS. The next thing is that normal check. It's different from proportions, right? Proportions has that discount double check with Jake from Stat Farm. We don't have that one, it's means. Means is the central limit theorem. We have a sample of 48, so we are good to go because the central limit theorem, CLT, requires us to be at least 30. So 48 is larger than 30, so therefore we are approximately normal. All right, so random, normal, and the last one is independent. We want to make sure that we didn't double dip into our samples here, that we didn't ask the same person twice. So we have to assume, Let's see, 48 times 10. So we have to assume, oh, wait, we don't have to assume because they give us the population size over 700,000. So 48 times 10 is 480. Is 480 less than or equal to 700,000? You betcha. So we're good. We didn't survey too many people. All right, so formula time. All right, so your formula, this is a one proportion, right? It's just one sample that we did. One proportion Z interval. Oh, is it a Z interval? No, it's not a proportion. Oh, Hamilton. Remember, we're doing means? And this is one of the new things we learned yesterday. All right, when you're doing means, we don't know the population data. We have to estimate it using the sample standard deviation. When you're estimating with a sample standard deviation, that means you're using a T-curve. How many T-curves are there? A lot. So many different T-curves. So we have to look up which T-curve we're dealing with based on the sample size, right? So the formula we saw yesterday was take your sample size minus 1. That's called degrees of freedom. And that will help you to find your critical value. All right, so back to it. This is actually called a T-interval. And the formula we saw yesterday to try and capture mu, I will capture mu, is x bar plus or minus t star times the sample standard deviation, but you have to adjust it based on the sample size. So square root of bar. All right, so start it. After we're done, then we'll declare what our degree of freedom was so we knew which curve we pulled to get the t star. All right, so here we go. So our sample was 6.208 on average, plus or minus. So now we're going to figure out the wiggle room. We want to be 95% confident, and our sample size was 48. So 48 minus 1 is 47. So let's head on over. 47. All right, 47 is not there. It goes 40 to 50. Now, the big mistake most people will make is rounding up to the 50. Don't do that. You want to round all the way down. All right, that produces a more conservative estimate. So we're going to round all the way down to 40. And if we're going to be 95% confident, that puts us at 2.021. 2.021. 2.021. There you go. Then we need our sample standard deviation, 2.576. And we'll adjust it based on our sample size, which was 48. I'll put a little bubble around that so it doesn't get crossed over. Okay, so at this point, I'm going to ask T.I. Joe to finish it. Put some sardine oil on this problem. All right, so head on over to step round tests. We're looking for an interval. There it is, T interval, number 8. All righty, so we've got the stats for it. The average household was 6.208 people. The standard deviation is 2.576. We took a sample size 48, and we want a confidence of 0.95, right? 95% confidence in our interval. So that yields 5.46 to 6.956. So the true number of people on average living in a South African household is somewhere between 5.46 and 6.956. Of course, you can round if you want, that's fine. The directions didn't say what to round to, so you're free. All right, so your closing line, we are 95% confident.
Carole killed her husband, failed to attack.
I did no such thing, Joe. We are 95% confident the interval 5.46 to 6.956 captures the true mean number of people living in a household in South Africa. There you go. All right, so we've got one more to tackle. All right. A milk processor monitors the number of bacteria per millimeter in raw milk received from the factory. A random sample of 10 1-millimeter specimens gave the following data. Construct and interpret a 90% confidence interval for the mean population. All right, so we're out to capture mu. So we've got the true mean, what was this again? Number of bacteria, yeah, true mean number of bacteria in raw milk. All right, so this one you're gonna notice has a little bit more space because, dun, 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 the conditions. All right, we only have a sample size 10, and we know central limit theorem needs us to have at least 30. So before we go and say that normal has been violated, there's actually a way around it. If you have the raw data, you can do a quick graph on your calculator to make sure there's not any outliers. If there's no outliers, it's safe to proceed. The reason why it's safe to proceed, if I go back to those notes from yesterday, notice these t distributions when you compare it to the z. All right, so standard normal is this one on top that goes real close to the x-axis. There's not a lot of wiggle room out here in the tails, but these t curves, they're a little bit lighter out here, right? They have a little bit more space under their wings. With that extra space out here, we're allowed to have a little bit more of a skew, right? So if your data leans a little bit left or a little bit right, it's gonna be okay because t distribution has more space out there. What they call this is robust. All right, t distributions are robust. What we don't want to see though are major outliers, but a little bit of a skew is okay. All right, so let me show you what I mean. Let's run through these conditions. You cool cats and kittens. All right, random. Random was stated. It was a random sample. And the next one is that normal check. All right, so unfortunately, central limit theorem can't be called upon. Instead, we're gonna have to type in this raw data. So head on over to Step World and edit and clear if you need to clear it. Mine's already cleared. I think it's because my calculator died and it reset itself. All right, so let's enter in these bacteria numbers. 5370. Missed that sound. I missed the sound of. All right, let me double check my numbers. Yeah. Looks good, looks good. All right, so once it's all there, we're gonna head over to second y equals to look at a graph. Notice right now all my plots are off. That's good. You can only graph one thing at a time. So in this first one, I'm gonna tell it to go ahead and turn on. And I wanna see the histogram of my data to see, you know, is it leaning left, leaning right? Does it look symmetric? What's going on with my data? So the data is in list 1, yep. And then the shortcut is Zoom 9, it's so fine, it's a friend of mine. Zoom 9, hey, hey, Zoom 9. Boom. All right. So there is a little bit of a skew on the right, right? A little bit of a skew on the right, but there's not any major gaps. This is not a major outlier. So we're okay, we're safe to proceed because these t distributions are robust. It has a little bit more space out in the tails to allow for little pieces of information to sneak in out there. All right, so what we have to write now is a picture of what we're seeing. All right, so we do have a slight skew on the right. Slight skew right. However, t distributions are robust. T distributions are robust. Safe to proceed. All right, t distributions are robust, therefore it is safe to proceed. No outliers. All right, and then the third check is your independence. Alrighty. This one's kind of strange. You can't say assume there could be 100 specimens of milk taken. I don't know. This one makes more sense to say each sample is independent from the next. All right. So we're going to assume here that whenever we take a sample, it's not impacting the next sample. All right. Formula time. Yeah, that whole 10N formula for independent really only makes sense in my mind when you're dealing with people, right? Or maybe like objects on a belt line or something. But when you're taking samples of milk, I don't know. If it makes you nervous on free response, like on AP exam, you could always write the 10N statement. You should be okay. All right, so our formula here, we don't know the population standard deviation. We're using these T distributions. So we're going to do a T interval to try and capture the truth. So our mean is somewhere on this interval. All right, so I need an X bar. I don't know what the X bar is. I need a simple standard deviation. I don't know what that is either. So here's where your calculator is going to do the work for you, and we're going to go backwards on the substitution. All right, so head on over to step 1, test, and we've got the T interval down there at number 8. Okay, so this time we have data. All right, so I'm going to click data. The data is in list 1. We want to do a 90% confidence interval. So change that to 90. All right. And then calculate. Oh, my tiger is barking at the prime delivery. Is that my toilet paper? I'm not joking. All right. So our X bar is 4950. Our sample standard deviation is 268. So there's everything we need for our substitution. Hush. All right, so X bar 4950. Leave a spot for your T star. We'll have to look that up in a minute. The sample standard deviation 268.45. We had a sample size 10. All right, so our degree of freedom is 10 minus 1, 9. All right, so we have to go to the 9th T curve, Okay, so the 9th T curve, boom, and we want 90% confidence. So down at the bottom, 90%. So that meets up at 1.833. So 1.833 is our T star. All right, and we already had the answer here. So our mu was 4794.4, 5105.6. All right, so that's the number of bacteria per millimeter. Ew, that's gross. I guess it's the good bacteria for your tum-tum. A lot of empty space. Sorry about that. Oh well, I write big. Come down here to the bottom for your conclusion. We are 90% confident the interval 4794.4, 5105.6 captures the true mean number of bacteria per millimeter in raw milk. Wow, think about that. A millimeter? Thousands of bacteria in 1 little millimeter? Ew. That's gross. All right, so there you have it. I hope you're feeling a little bit better about it. Tomorrow we'll practice it again. So practice, practice, practice. We will keep on practicing. Ooh, I look fabulous. You like my dress? It's vintage. All right, well, Carole Baskin here signing off. Hope you have a good night.